welcome back and welcome to lesson 11 in the Houdini environment beginner series. We're going to continue where we just left off in the last lesson, and we are now going to look at how our little procedural garage was set up for this particular wall of the house. So again, these are the maps in our network where we're actually going to be working for this lesson, and that is here. If you zoom out, we're going to be in this section here between these two yellow lines. So the general workflow for this garage is, as we've discussed last time, we have these primitives that we're randomly sorting on our object, and then we're selecting different primitives based on the probability we create up here with our random probability selection. Then we select and isolate that single primitive, that wall. We'll create another rounded shape, which we've done in the last few lessons. We'll cut that shape from the garage, extrude it, and then add a few extra details. So we'll place some cubes in the corners. Looks like we'll inset the face on the top. We'll actually cut a seam, another Boolean seam around this bottom of the edge, and then we'll add some thickness, and then we'll Boolean again, I believe we actually do, to give this little inset ridge on the base. And then we'll cut two windows and then add a garage door, which I think is actually similar to the way we've done the garage door in the human door in the previous lessons. So lots to cover. We're going to jump straight into it, and the way we're going to do that is we'll actually go back up here because I really want you to understand what's going on. So again, we get our house incoming here. We've got this area primitive attribute that we've measured and stored on our primitives. We then split out the horizontal planes, horizontal primitives. We can delete those or split those. And this essentially, and I'll show you, is the same as a blast in this use case. Because I want to say I only want to keep the horizontal primitives. So if I just do blast, horizontal, and delete non-selected, we'll see this will give me the opposite end of my split. Oops. So you see the split in this case, it's doing the blast, but it also does the invert. So it keeps one side and then splits, does exactly what it says, to the other side. Again, we sort our primitives randomly, and we sort them randomly so we get a random seed for each frame. And then we're splitting at 1, which when we select a split node, the left input is what is previewed. You see the right, split it again, the right. Now we get 2 primitives, and then we're assigning our random number. And this, remember, we showcased because we had that little issue last time we actually fixed, where we were multiplying our primnum by the frame number, which gave a constant seed for primitive 0 on every frame. So we actually debugged this together, and I showed you why we needed to fix this to actually get the result we were expecting. And then we assign it a group using I group underscore tunnel equals 1. 1 equals true, so it is in the group. 0 equals false, and by default, it will give you a 0. And then we blast everything that's not a tunnel. And on this frame, it looks like we don't have a tunnel. So let's keep going until we get one, and here we go. And then the reason, again, we have a for each loop is because there's a chance that we'll have 2 garages. I'll see if I can find one. There we go. We have 2 garages, and we want each garage to be operated on individually. So then we can do details such as adding windows and merging and extruding, but we don't want them to happen to both together. We don't want them to be extruded together, because then we might get weird placement in between, or we might extrude and the normals might not be what we expect. So operating on each primitive individually lets us get a little bit more of a controlled setup. And now this is another example. This is the tunnel. When I select here, it's giving me a previously cached setup for my loop. So what I could do to get what I'm expecting is I can recache, reset the cached pass, and now that will give me the correct primitive coming in. So the general workflow for this, we're going to, again, cut the shape, extrude it, add details, and then add windows and doors. And we're going to start first. Looks actually like we keep a main back wall, which we create, again, using that normal trick. We round it to the nearest integer, so it displaces it along the Z and X direction without adjusting anything in the Y. And then we add normals probably. It looks like not. We do not add normals. We do add normals later. But so this will be the back wall, which we have as a shadow catcher inside, and then also to give more resolution to the object once we start to mesh it. Looks like my scene, again, is running a little bit slower. So we'll see if I can fix this we'll try resetting actually the scene view. So I'm going to do a new pane type, viewer scene view. I'm going to X out this one. I'm going to repin this to 1. I'm going to ghost or hide other objects. Select our node, and I'm going to hit space G. And this sort of sped it up a little bit, but if I do need to restart, I will again. So we'll see how that goes. So again, this was just that back side of the wall, which we then merge in and name it stone, because we're going to texture it as stone later in Solaris. Again, we can arrange and place these nodes. Next up, we're going to take, it looks like the same object, scale it down, place it in the middle, and now what we're going to do is we want to create, I believe, a shape to cut out of the garage door. So this is the object coming in, and if I do a null, I can see the exact object coming in. And I want to create this shape here, which is going to be used to Boolean from this larger shape. So this comes in here from the match size, and this is done actually to place a smaller version, it looks like. Let's see what happens without it. All right, maybe this was done to fix a Boolean issue. So I'm going to transform this down to make it smaller, match the size to arrange it to where it was on this incoming geometry, create the normals, and then I will create a bound, scale it down again, and match the size. And then again, we'll use that measure trick where we displace along the X coordinates and the Z in this case. So we measure, not necessarily the X and the Z, we just want to displace along the large areas. So if I go primitive, ramp from attribute, area, and I set this to maybe 10, and then set this to red, and then this type 1 to yellow, or even a different color, we can see for this group peak, we're taking areas larger than 3. So these green sizes, these green shapes will be inside this peak group, which we then peak with a peak node. And the name doesn't have to be the same, so peak me. It won't peak unless we correct this name in our group. So peak me, and there we go. And then group the top, bevel the top, peak it again, normal, and then I cut that from here. And it actually looks like if I disable this bound, or actually disable this, I want to figure out where the bottom seam was that was causing issues, because I could probably have peaked the base of the Boolean, which we will see if I did. So normal, we'll do null, which lets me select an easy side here. So I'm taking this object, I'm gonna hit escape to hide that little arrow, and booleaning that with this end here, which we can see actually, if I do space 2 takes me to top, this takes me to front. If I hit wireframe, you can see this incoming object, this normal side here, which is this larger area, does extend past the bounds of this bottom side. So space 1 will bring me back to perspective, or I can change that here. And then we cut that out. We do surface, solid, and intersect, as we've done before. Round the normals again. And then we want to extrude this in this direction, which is done by a point normal set to attribute, which we've learned before again. So poly extrude. If we extrude it here, it's going to bring it slightly up towards the Y, but we want to set point normal and existing, which lets us use this value we set here manually with a wrangle and set on our points. And then this is the random function again that I've done to randomize the extrusion length, excuse me, of our garage and how far it goes. And this looks like it's going to be the end door, which we'll keep going, and I'll show you exactly what's going on. So this is extruded here. We take this end, we extrude it again to give it some thickness. We do a bound and a Boolean to get the top. And then it looks like I need to get some kind of ridges here on the bottom. And the reason I actually did this is because I want this door to be partially opened. So when I bring this normal in, this bound with the random lower padding will open and close the garage door random amounts. So it'll clip off little areas. Maybe it'll clip off 1 meter, 2 meters. And then it looks like for each house, maybe the doors are more open or more closed. But this was the solution I came up with for creating some variation between those. So not every garage door is the same height. So they're not all open, they're not all closed. They're a little randomized. And do a color. And I'm actually going to do another sub net, and I'll cover this black, just to remember that this was our door. All right, next up, let's look at this side. Whoops, I'm going to escape. That actually was the I button here to bring up information, and you can also middle mouse on the nodes to see what's going on. So we get our incoming geometry, which we shrunk down a little bit. And then we Boolean that with this side here, which we've created. And now what we want to do is we want to extend the garage. And notice how in this Boolean, we kept the inside because we were making this garage door. What we want to actually do is we want to keep the opposite. So we're going to do subtract rather than intersect. We're going to round the normals. There's also a few ways to do this, but this is the way I chose to do it. We're going to extrude, which lets us extrude it along while keeping it flat on Y. And then again, a random distance. And it actually looks like this. Here we go. So this one, it's extruding randomly, and then this one's also extruding randomly. But we'll notice that they're always extruding the same amount. And the reason is because the seed is always set to $F. And this one is just extruding the random amount minus 0.4. So the garage door will always be minus 0.4 units away from the end of this door. And there's, again, a few other ways to do that, but this is the way I chose to do it. I could have also matched the size or maybe placed it a few different ways, but this worked for me, so I kept it. And then add some normals to fix that little issue. And then here, looks like we'll do the top. So here we must actually group by top. This one we don't actually need. Maybe that was a different thing I was using. So we'll hide that and see if that works still. We're going to extrude point B. Maybe actually that was used. All right, well, let's find out where our top attribute was created. Looks like that's not being created. What we want to do is we want to group the top and we want to extrude it up. So this might be a little bit of a messy way to do it. So I will actually try to redo it now so you can see. First, let's actually look on our geometry to see what groups we have. So we do have a top group, but nothing's in it. So what I'm going to do is I'm going to create a new one. So top, we'll group by primitives, and we'll group by normals, and we'll do normals facing upwards. And there we go. Now what we want to do is we want to extrude this up. So we're going to poly extrude our top group. We're going to extrude it up. Actually, did we want to extrude it? We wanted to inset a little bit before we extrude. So let's do that. Let's extrude top, and we're going to bring it back to 0, and we'll inset it a little bit, maybe 0.15. And then we want to get this new face here, which we can see is the output front, and we're going to say extrude front. And we'll name this to inner top. And now what we want to do is we want to extrude this inside face, the inner top face, a little bit upwards. So we're going to say, okay, let's get inner top and extrude it upwards. There we go. And let's maybe see, I guess we don't do it again here. We do inset it again, and then that's used to place these points on the inside. So let's try to do that. So now what we want to do is we want to add a little corner box to each of these points. And the way we can do that, actually, I'm going to move this around here. Looks like here, first what we did is we extruded it inset. We split so we only get this extruded side. And then we copied our points to those points. So we copied our box, to those points. And then we merged that with the existing side. So let's see if we can fix this together. And I'll actually delete or disable that stuff. I'm going to disconnect this, and we're actually going to try to redo it here so you can kind of see how it is put together. So we definitely want to keep this side. I'm going to arrange this a little bit differently. And the other thing we want to make sure is we don't accidentally connect this extrude to this wire that's going under here. So just one thing to keep aware of. We can maybe slide this out of the way so we're not accidentally dropping networks on different parts of the network that we don't want. So we want to copy those cubes to the inside of this top face. And we'll do that first by taking this one. We'll say copy to me. And we can do another extrude. And we want to inset this point here by an amount. And we only want to keep this part. So what we'll actually do is we'll say front, and we'll say keep, and then we will blast everything but that part. So now all we want to do is we want to save this top inside area. And keep. And delete non-selected, and there we go. Now, what we want to do is we want to take these points here, and we want to add some boxes. So we can do that with box. Do copy to points. We'll take the geometry we want to copy and the points we want to copy them to, place them, and then we can merge them together, and we'll make our box a little bit smaller. So we'll make it 0.5. And there we go. And this does intersect the inside, but since we're going to be doing a V2B remesh later, we actually don't care about the inside there, so we'll actually just leave that. And there we go, and we'll figure out what happened for this side. So now what this does is this creates this inner sweep area, which we'll use to Boolean and cut out this bottom ridge. And the way that's done is, again, we get this input geometry. We're going to create a line, space G to frame. We're going to create a line along the base of this geometry. And then we're going to sweep that line to give it thickness. And then we're going to Boolean this object here minus that new line with thickness. So we'll create a grid, which will be our big cutting surface, which we'll know is 100% bigger, or not 100%, which we definitely know is what I meant to say. We definitely know it's bigger than this object. So we do a match size to place it in the middle, which we did a little bit of an offset, actually not the middle. We took the grid, match sized it to the minimum, so we placed it to the bottom, and then we offset it by 0.5. So it will be 0.5 meters, this seam above the floor. We could change that here by middle mouse clicking and dragging. We'll leave 0.45 maybe. Now that we have this curve here, what we want to do is we want to sweep it and give it geometry. And the way we're actually going to do that, and maybe I'll show you two ways, because why not? The first way is going to be orient along curve and then sweep. And we'll sweep with the square tube. So if I do a sweep node, that will be square tube, and that's sweep. And then there we go. And we'll actually notice for the Boolean, the resolution inside the cutting area is defined by the resolution of the cutting surface. So this has a lot of resolution. So when I cut, it will add that resolution to this new object. But if I don't want these lines, I could change the resolution on my sweep. Now you see they go away because I have changed the resolution of my cutting object. So that's one way. Now if we wanted to do it a different way, what we could do, and I'll tell you actually before I do it, is I want to take this object, I'm going to duplicate these points downward, create a surface in between those points, and then I'm going to extrude that surface to be thick. So I'm going to do a poly extrude. We might run into an issue here, and I'll fix it if we do. And that's the issue I was expecting. So we can either poly extrude here and then poly extrude again this direction with a back switch, Boolean, and then set this here. And if we did want to do that, what we could do maybe for our extrude, we could extrude negative. Actually, maybe we could, well, I'll show you this and then we'll see the issue that's going to come up. Boolean here, and then we have that object. But now we might have a Boolean issue on one end here where it's not extending far enough past the back of our object. So the way we want to fix that is we want to make this thicker. And the way we could do that is with a peak. And there we go. I peaked a little too much, so let's do a small amount. Let's do 0.05. And there we go. Now we Boolean it, and because this cutting area is farther than the inside of this object being cut, we'll have a clean cut there. So that's another way to do it. You can either sweep objects, sweep geometry around a curve, or you could actually use that curve to create the geometry itself. And there's really no correct way to do it. Again, it depends on what you're using, and you might want to do this way if you're trying to copy maybe a crazy shape, maybe circular or like a extruded decorative shape here. But if you want to keep it simple, then you could also do extrudes and use those. So I'll switch back to 0, show our Boolean. Which looks like it's not doing what's expecting, so let's figure this out together. And that is an odd thing that just happened. All right, so that's some of the things. Sometimes Booleans do get a little bit weird. This was showing them merged together, but it really was on subtract, and I didn't change anything. All I did was reset this node, and it seemed to fix itself. So Booleans are weird sometimes, just keep that in mind. And then again, same similar idea, but we actually do with windows. And then I'll walk you through this, the rest of the stuff, which we just group it actually, and then merge it together. But for the windows, what we do is we get this object, which was our main thing here, our main window, or our main garage, excuse me. We are going to keep this group of extruded side, which we created here on this poly extrude node. We're going to delete, it looks like, the inside points here. So what I wanted to do here is I want to only get this outside face and this outside face. But the way I chose to do that was to delete these inside faces. And the way I deleted those was I made a bound, which was the same size as this object. Then I group points by this bound. And technically what I might want to be able to do is I might want to inset this padding to a negative value. Oops, I don't want that. Negative 0.1 on there, and I want this one to be positive. So I want to group these points, and the reason I just changed this padding is because if you're grouping on object, I'm going to put 9.1 again, and you have the bounding region on the exact location of the points, sometimes it might group it, sometimes it might not. So I want to have that intentionally not on those points outside, and this should still work. All right, looks like those didn't get fixed. So we will see if we can get these grouped. And the reason I can't extend this in the X direction is because if I do, it'll fix it for this area. But then if I get a garage that faces in the Z, we'll have an issue. So let's see if actually we can find that, and I will test it. Garage facing in the Z. And let's see if we have our issue, which is still giving me that X. So I'm going to reset my cached pass. You see slowly, this is, keep an eye on what just happened actually. And then I'm going to go back and I'm going to see if this would work. And it looks like it won't because we had extruded that and extended it on the Z padding. And you see it broke it. So this must have just been an example where I tested it a few times and it worked with the bound exactly on the object, and it does look like it works. So I might leave that there, but if you have an idea on how to actually fix that, that'd be cool for you to try to do. So I won't brainstorm that now, but I'm sure there's multiple ways to do that. Now let's find a tunnel again back on our X-axis, and there we go. And now what I'm going to do is I'm going to select down here. You see, notice how this node up here is selected, and it's in the negative X. When I select down here, it'll push it back to Z, and you might say, why is that happening? And the reason is because our for each loop has a cached pass that's been saved. So we're going to reset on our loop, cached pass, and there we go. And I'm showing you all these things because I want you to be able to actually work in Houdini and not have these unexpected things happen. So it took me a while to actually figure out why things like that were happening, and I am trying to help you not have to work through those. So we want to figure out now how to get, it looks like we want a line. So I'll do a grid, match the size to place it in the middle, Boolean, resample. So same way we did the windows, and I'm going to use this one, blast, sort, blast, and then this. And the reason actually I did this area, and I'll show you really quickly actually. First, this match size, I could offset the window height if I wanted to by that justify Y. So that's one thing to know. But the reason I needed to do a for each loop on these primitives is because I want to remove, and I'll show you really quick, I want to remove primitive 0, primitive 3, primitive 4, and primitive 7. But I don't necessarily know how many points there will be. So really what I want to do is I want to remove the end points, but keep the inside points. And if I deleted point 0 and point 13, then that would leave 7 and 6 without being deleted. And the reason I can't delete those is because, well, the reason I can't manually delete those is because I don't know how many points they're going to be. And I actually could probably reference the segments and write some vex to delete those points, which might be easy, but the way I chose to do it was to do a for each loop. So what I'm going to do is for each of these primitives, so for this line and this line, I'm going to go through and I'm going to delete 0, sort, and delete 0. And then this means I'll do it for each of them. So I'll do it for this line here, this line, and then I'll do it for this line here, which is what I just selected by using the block end of our for each loop and selecting single pass. So that let me remove the points while keeping this procedural, so I could technically now have, and I'll show you, I'm going to disable this. I could technically have as many of these points as I want, but I will never have them on the outside here. So if I click resample, more windows are being added, but they're never on the outside, which is what I wanted. And again, there's definitely lots of ways to do this. This is the way I chose to do it, but I do actually encourage you to maybe figure out a way to do it with Vex or with VOPs. So lots of ways to do lots of things, which is, again, the coolest part about Houdini. So then what I want to do here is I want to now, let's see what this is. Looks like I want to cut those out. And when I do cut them out, I wanted them to be a little bit bigger. Actually, no. This is going to create the window geometry. So this here, I cut the geometry out to make the holes in the windows. And I'm going to offset, I'm going to put our windows back up by fixing this match size. So there we go. But what I wanted to do is I want to cut the windows, keep those as windows, and then I want to add some geometry inside the windows. You see, I'm going to template this flag inside here, but I want them to always intersect. So I always want the window wood, which is this thing here, to be bigger than the actual hole itself. And that's done with this peak. So here, when I merge these together, and you'll see if I actually peek this in the negative direction, this wooden frame, you see how it intersects this wall? I could shrink that. All right, 0.2. So I could shrink that so it's smaller than my window, but because I'm trying to create like a shutter or like a window cover, I wanted that to always be bigger than the window. And again, W is going to wireframe. And you see it's the exact same size when it's 0, and it most likely wouldn't have any issues. But maybe if there was lights inside the garage and this window was cut all the way through, then we would see little artifacts in between or shading artifacts. So I just wanted to increase with a little bit of an intersection here to intentionally block all that light. And now actually, if I did want to cut all the way through, since we are learning, let's figure out how to do that together. I could scale the size of my window. And there we go. Looks like scaling my window along the Z-axis would give me enough of a cut to cut all the way through. And now this actually gives me 2 windows, but I want to get one back. So what I can do to fix this is to get a cut. So I just want to get the inside here, and I could do that a few ways, but let's think for 1 second and then figure out how to get that. So I could group these outside faces and then transform them back in, or what I could do is this. So I'm just going to duplicate the copy to points. I'm going to use one shape to cut the hole, and then I'm going to use one shape as well to do the actual window. So I'm going to put this back to 1, copy these to points here, and then when I connect this to here, that will give me this Boolean cut again. So this Boolean cut is giving me one face because it's extending and it's only cutting through one side of this wall. You see, it doesn't cut through the second side. And I split that up, and I could have fixed it a few different ways, but this was a fine way to split it up because it is easy to read and it was easy to set up. And then here I peek it. And we'll merge and see what happens. And this peak, I think I just used to indent it a little bit. Yep, there we go. So it's inside the actual wall. And then I add some extrusion. And then a group here for metal and a group here for wood. So there we go. And then normal. And then this for each. I'll show you one more time. If I go up to the top, this again had some windows or some walls that would have 2 garages. So inside here, I can look at one of them, and at the bottom, I can see both my garages. So let's let this work individually, and this is actually a really great example. Let's figure out why this breaks. So we're learning together, so we're going to debug this and fix this together. So first way to figure out how this breaks is I just want to operate on this single half of my geometry. So I'm going to go to the for each loop and select a single pass. And looks like that single pass 1 will be this geometry. Now, I want to figure out where we're cutting this, which is most likely in this area we just changed. And let's find, I'm just going to look through this network until we get a problem, which it's here. And there we go. It looks like when we created these windows, we scaled them up a lot. Okay. This is a good example. So what I mentioned earlier was when we had X and Z, we don't know which direction our garage is facing. So at the end, we have one direction that is X and one that is Z. And we want to be aware of that, and we want to make sure that our system is robust enough to not have to have this issue. So the way we could fix this is we could just split this if we were not doing it the correct way and say, okay, for all the Z's, do one part of the network, and for all the X's, do the other. But the way I'm going to try to fix this is I'm going to try to fix this part here, and I want to orient these boxes the correct way by using our normal attribute. So let's see. What I want to do is I want to take this face here. Actually, I want to take this face. Whoops. I want to use these normals that are up here, and I want to add these normals to our points. And I want to use those normals to align these window boxes where the long end, the Z end, is pushing away from the planes. So you see, the long end is not pushing away. The long end is always pushing in Z. And the way I can fix that is I can add a normal attribute that will be used by the copy to points. And the correct way to add that is going to be an attribute transfer. And I want to transfer attributes to the points I'm copying to. So I'm copying to these points, and I'm going to add a null so we can select that. These are the points I'm copying to. And you see they don't have a normal attribute. So when Houdini copies these points, when it copies this box to these points, it's just keeping the same orientation that the box originally had, which is this direction. But I want it to face outwards. So the way I can get it to face outwards is by adding normals to these points that face in the direction I want this box to face. So let's do that by transferring normals. So I'm going to transfer normals. And where do I want to transfer them from? I want to transfer them from somewhere that will have the correct normals. And if we look up here, I'm going to hit W for wireframe. This plane, this face, this primitive, has the normals we want. So we need to get the normals from here. We need to put them on these points in order, to actually copy the boxes in the correct direction. And I'm going to do that by doing a normal. So I'm going to recompute normals on these points, not the vertices. Now you see this blue. And what I'm going to do is I'm going to take this blue, this normal, and I'm going to transfer it to here. So now these points have the correct normal that I need. And now when I copy here, it should be aligned in the correct direction. So now without this normal, it's not going to align our windows in the correct direction. So this is why it's important, what I was mentioning, knowing what's happening with your attributes can be really important, because that just let us fix this issue by knowing how Houdini works with copy to points, how the normals work, and then how to orient objects we're copying. And now let's see if we fix that issue. And there we go. It looks like our little issue is fixed. And let's see if we can find another one with two garages. And then if we disable this little, where was it? Right here? There we go. So we just walked through this whole network, not really, this little section here. We figured out that this single node was what was causing this issue on our setup. We debugged how to figure out this setup. And then we learned that by adding an extra attribute and transferring it from an earlier section of our network, we can fix this modeling issue. So there we go. That's a little cool setup there. I actually should have thought of that edge case, but I didn't. So that's a good example of me not thinking necessarily about everything that can happen and then having to work through live to actually understand what's going on, so then we are equipped to fix it and then to get the results we expect. So there we go. I'm going to find another one, and then we'll end the lesson. Awesome. So that was a great lesson. We learned a lot. Ran into a few issues, but that's why we are learning together. And I want to showcase that those really come up a lot, and just the better way that you solve them, or the way you solve them, is really what helps you become a proficient Houdini artist. So that's going to end the lesson there. And in the next one, we're going to keep up, actually lesson 12. I'm excited for this one. It's going to be fun. We're going to create some brand new geometry, and I might even show you how to create a few extra tips and tricks for learning. So awesome. Thank you so much, and I will see you in the next video. Have a good one.